Hey, what's up, everyone? My name is Josh. I'm a full stack software engineer, and I'm going to be giving a dry run here of my talk that I'll be giving at the AdvancedJS meetup in New York City in October 2024, entitled Rough.js Starters Anthem, Animating SVGs with a Hand-Drawn Style. And in this talk, we're going to be talking about the Rough.js library for drawing hand-drawn style illustrations on the web. We're going to be talking about how I forked it to add animations like you're seeing here. We're going to dive into the wild world of SVG animations, and we're going to talk a little bit about different strategies for forking open source NPM modules and consuming them in your own projects. So diving right into Rough.js. Rough.js was released in 2017 to create drawings like some of what you're seeing here. And in 2018, it got picked up by Hacker News, and its popularity kind of took off. It became the second most visited post that year, and it's up to almost 20,000 stars on GitHub now. There's a whole little ecosystem that's been built up around it and different things built with Rough.js. It allows you to draw all kinds of different shapes, so squares, circles, arcs. It allows you to put in different sorts of fills here, zigzags, crosshatch, dots, so forth. It also lets you draw more complex SVG shapes like this US map here. So you can pass in any kind of SVG shape into it and render it out in this sketchy hand-drawn style. Here, for instance, is a seasonally appropriate set of drawings, some happy Halloween skulls, and you can see these are drawn with different levels of roughness. So different amounts of sort of hand-drawn style imperfection, which is controllable. That's something that the library exposes and lets you change. So a quick little dive into the ecosystem built up around Rough.js. Some of the main players here, you have Excalibur, which is a drawing app that lets you make these drawings with the hand-drawn style. You have Rough.js, which I think is my favorite. It's a complete charting library that uses this drawing style. It's got all kinds of different sorts of charts it makes available: line, network, has pie charts, scatter charts, bar charts, and the like. You can draw various fonts with Rough.js. You get the font shapes from OpenType.js and then pipe that through to Rough.js, and you can render out any font you'd like in this style. It's also a project that lets you render out any of the awesome font icons in this style. So here's a little demo of some of the options and how they look with the original on the left with perfect lines and the sketchy rough version on the right. Then from the author of Rough.js, there's a few projects. So there's the Wired Elements project, which is a bunch of web components like buttons and inputs and selects and spinners and all that kind of thing. Lets you give your website this kind of hand-drawn feel. And then there's the Rough Notation library, which lets you draw these sort of animated annotations, which kind of reminds me of like a college professor marking up your paper, at least if you're of a certain age. I'm not sure that they're still printing out papers anymore. So how Rough.js works under the hood, at the end of the day, roughness is a function of randomness. If you have a line with 2 points, those points are placed in a circle, and then rather than drawing the points as given, there is a random point within that circle that's drawn, and the radius of that circle determines just how rough the drawing is. So a small circle will look closer to the perfect shape, perfectly straight. Wider circle will look much sketchier and rougher. Here's a quick demo of the roughness parameter. You can see it starts off very straight and then just kind of gets rougher and rougher and spins out of control, and as you start to get out there, it looks like something a toddler might have drawn, and it gets pretty wild. Another thing that Rough does is applies bowing to lines. So if you see the hand-drawn lines on the bottom there's some bowing there, and they're not perfectly straight. So in addition to randomizing the endpoints of the line, there's a couple points along the line that are chosen to apply this bowing effect. For circles, for hand-drawn circles, as you'll see on the left, they're usually not perfectly closed, and that effect is mimicked in Rough.js by not perfectly closing the circle, but closing it on the second to last point and giving it that kind of hand-drawn feel. And then there's the filling algorithm. So the default fill is called a hasher fill, which is what you see on the right there, those lines. The way that those are applied is the shape is scanned from left to right, starting at the top and working its way down. And when the scanline algorithm hits one side of the shape, it starts drawing the fill, and then when it hits another side, it stops, and so on. And the shape is filled that way from top to bottom. And then the angle of that fill is configurable in Rough, and the way that works, which I thought was pretty interesting, is that the shape itself is rotated to the angle that you specify, as you see there on the right, and then the scanline algorithm is applied, and then the whole shape plus its fill is rotated back to the original position, and that's what gives it that the angle of the hasher fill. And most of the other fill types are just variations on hasher fill. Hasher or hasher, I'm not sure which pronunciation is right. So you have a zigzag line, which is just a hasher fill that's joined, all the lines are joined. You have a crosshatch, which is two hasher fills laid on top of each other. You have dots and dashes that are just dots and dashes laid over the lines instead of the lines themselves. So that's an overview of how Rough works. And for the next part of the talk, I'm going to talk a bit about how I went about making Rough.js animatable, how I went about forking it so that it could be animated, and then I could use it in one of my personal projects where I wanted to create these drawings that kind of had a hand-drawn fill that looked like they're being drawn in by hand in front of you. And to get there, let's start with just an SVG basics refresher. So as you may remember, raster-based images like JPEGs and the like are just a bunch of pixels. They don't scale very well. They get blurry as you make them bigger. An SVG, which stands for Scalable Vector Graphics, on the other hand, scalability is right in the name, and it's infinitely scalable because it's just a set of instructions for how a shape is drawn, and it works at any scale, as you can see on the left. And the key part of an SVG is the path, which describes the lines in the SVG. And a path is a series of commands. You give it a coordinate in 2D space, and the commands are things like draw a curve or draw a line from this point to another point, close a shape at this point where the lines connect, or move the cursor without drawing a line. Like if you were going to draw two unconnected lines, you would use a move command, which we'll come back to in a minute. So that's how SVG would work. And SVG animations, this like drawing in animation style, how it works I found to be pretty surprising and pretty kind of head spinning. So let's dive in. So we'll use this shape as an example, which comes from CSS tricks. But if we have this kind of shape and we want to animate it so it's drawn in, there's a few properties we can use. We can add dashes with the stroke dash array. It's called an array because you can have multiple dash sizes, but we can add dashes to the line. We can make those dashes a lot longer. And then we can start animating where those dashes are with the dash offset. So if we start with 0 dash offset and animate it to a dash offset of 1,000, you would get this kind of animation that you're seeing on the bottom. So if we put those concepts together, we can get our animation. So first, you start with getting the length of the path or line in JavaScript. Then you create a dash that's equal to the length of the entire shape or line. And it'll be rendered out in a way where the dash is not visible. The dash effectively ends at the end of the line or shape. Then you offset the dash and you move it backwards so that it covers up the entire shape. So now the dash is completely over the shape, and the shape is hidden. And now you can use CSS animations to animate the dash off of the shape and reveal it, which gives you this kind of drawing in effect that you see on the bottom here. So refresher on how that works. You have the dash array, which is the length of the shape, the dash length. You offset the shape of the dash so that it's completely covering up the shape. And then with CSS animations, you move the dash off of the shape, unhiding the shape. You can extend this concept with delay to stagger multiple lines to look like they're being drawn in order. So if you have a 2-second animation for each line, the first line has no delay, so it starts immediately on load. And then that inner line, the inner circle, has a delay of 2 seconds, so it starts as soon as the outer line finishes. And when I heard this, I just couldn't help but think, man, CSS is so weird, and just led me to think, like, why is CSS so weird? If you've worked with CSS over any length of time, you've come across these kinds of kind of hacky solutions to things. This one seems to me to be particularly hacky, but there's numerous times where I and others have come across this kind of thing in CSS. So thinking about like why is CSS like that, with a little help from this Mozilla video, I think what it comes down to is that CSS is a super declarative language. You're not telling it exactly how a page should be laid out or things should be drawn onto the page. You're describing intent at a very high level. And it kind of has to be that way because CSS is designed to be used across any browser, any operating system, with any user settings, all kinds of different devices. The language is built in a way where if the browser can't figure out how to apply what you tell it to do, it just ignores it and falls back to its default styling. So it's designed to be this incredibly flexible language, which is why it's so declarative. And that's great when the spec has a way to declare what you want. But if it doesn't have a way to declare what you want, like SVG line animations, for instance, it falls on the community to come up with these super hacky but very creative ways to solve a problem. So on the one hand, I'm always just kind of mystified by this kind of reasoning and always have a hard time wrapping my head around it. But on the other hand, I have a lot of respect and admiration for the just immense creativity that people have in taking these rules and using them in unintended ways to produce, interesting effects. So that's my little aside on CSS and its weirdness. So back to Rough.js, if we apply that SVG animation technique, it didn't quite work. And the reason it doesn't work is that the paths, which are the command sets for Rough.js, are incredibly complex. So a single command set would encompass all of the fill or all of the outline. And it's just too complex to have the animations work the way that I wanted them to work, which is the way that it would look being drawn in by hand. So that's what led me to fork Rough.js and see if I could add animations in the way that I wanted them to look. And a few things had to be done there. So first off, the DOM structure of the SVGs had to be changed quite a bit. So rather than having one super complex path for the fill and one complex path for the outline, I actually had to split those drawings on each move command. So every time there was a single line is drawn and then you move the cursor to another position to draw the second line, you actually split that into two separate path elements so that they can be animated sequentially. And that kind of looks like this. So on top, before, you have one super long path for the outline and one super long path for the fill. But afterwards, you're going to have lots of paths, and there's going to be one of these path elements for every single line. The next thing to do to prepare the DOM structure is that SVG elements are drawn onto the DOM in the order that they're given. So the DOM order has to match the animation order. So here you see, for example, there's this double box outline, and for Rough.js, the outline, the order of the outline lines had to be rearranged to match this animation order. And this is an example from the Rough notation library that the author wrote, and I definitely took a lot of guidance and inspiration from his approach to starting to animate some of these shapes. So once I had the DOM structure prepared for the SVG in the way I wanted it, is ready to start animating. And the sort of high level approach there is loop over each path in the outline, aka line or curve, and then in the fill. As I discussed before, apply a dash that's the length of the line to cover it up. And then each line's animation duration is going to be proportionate to its length. So if it's a small, short line, it's going to have a quick duration. If it's a long line, it'll be a longer duration. And then you want to delay each line to start only after all the prior lines. So you have to keep a running tally of the duration for all the lines in the group, and then start the next line after all the other lines have finished. And if you want a zigzag effect, like for the hasher fill, you have to alternate between a positive and negative dash offset, so the direction in which you move the dash off this shape. And then if we want to stagger multiple animations, the approach that I took basically is animate the outline first, delay the start of the fill until the outline is finished. I added a prop to give the user control over how much of the animation time you want to give to the fill versus the outline. And then say you had multiple shapes, you would just extend that concept so that you would delay the start of the second shape until the first shape is finished. And the results look something like this with the different fills. So this is the hasher fill. You can see the sort of zigzagging effect with the toggling the offset direction of the dash. There is a zigzag fill effect itself. It looks like this. We have crosshatch, which is just two hasher fills layered on top of each other. There's a dashed fill, which I really like the look of. There's dots, also pretty cool. And the newest addition to Rough.js was zigzag line, which I think is really cool looking and really looks hand-drawn. So once I had forked Rough.js to add this, then it came time to consume that fork in the project I was working where I wanted to use it. So I wanted to just talk a little bit about the different strategies for forking NPM packages and using them. And it's much easier than I would have thought. So you have a couple options. If you have a really small change to a node module, you can use this patch package and just modify it in place. The problem there is you're dealing with whatever the distribution is, so that might be minified JavaScript. You're almost certainly not getting the TypeScript through NPM, so it's really only for very small things. And if you're like me and you work in TypeScript whenever you can, I think you want to fork the library and have all the nice developer experience of working in TypeScript as you're making your changes to the package. And setting it up is not that hard, actually. So in the fork package JSON, you can add this prepare step, and what that does is says if someone else is going to consume this fork, rather than publish it to NPM, I'm just going to describe the build step. So when they run npm install, I'm going to run the build script from the fork. And then to consume the fork from GitHub is super easy. You just point it at the repo. You can even point it at a branch. And then it'll pull in the repo. And with that prepare step, it'll run the build step for you. And you can use it just like you would any other node module. And as a result, I was able to use Rough.js in another project I was working on, which looks something like this. Yeah, so Story and conclusion, not sure I have one other than to say that we've got a lot of power as developers, and you should definitely feel empowered to make changes to the open source modules you're using. Um, Hopefully you and the community will get some benefit out of it. For my part, I'm still working through my changes to Rough, but the end goal is to merge it back into the main Rough repository and release it to the world. Yeah. So last couple things I'll say, shameless plug for a completely unrelated project I have called Lintier, which is a open source package that will install ESLint and Prettier for you in a TypeScript project, which I always need for any project, but I always hate setting up. So I wrote a package that will do everything for you, install the dependencies, and write all the configs.